Hello all, welcome back to the problem solving session on the topic DBSCAN algorithm. It's a density based scanning algorithm. In this case, I have considered 12 data points and with an epsilon of 1.4 distance and minimum points should have 4. So consider the 12 data points are 2, 2.5, 1.52 and till to 4.5. And 2D view, if you plot all those image data points in a 2D view, it will look like this. So as per DBSCAN algorithm, it is straightly you can say you have two clusters. One is center data points and other are outer data points. And see if you see the outer data points, there's a huge gap. So density algorithm may fail. Fine. So let me give the number notations of each data point as 1, 2, 3, 4 till number 12. So in this you have a number of distance measuring methods, Euclidean, Manhattan and Minkowski. And in this example we are going with Euclidean distance method. For example, if there is two data points, consider the first data point. In this example, the first data point is 2, 2.5 and P2 is second data point is 1.5, 2. How to measure the distance, which is equal to distance of x, y, which is equal to square root of first point in the data point P1, 2 minus of first point in data point 2, that is minus 1.5 whole square plus second data point in first P1, that is 2.5 minus of 2 the whole square. If you simplify, you will get 0.71. Same way, we need to calculate with respect to each and every data point starting from 1 to 12. For if you have calculate the distance between the first data point and the first data point, it will become 0 since it is one data point. So same data points are same. So 2 minus 2 it is 0 and 2.5 minus 2.5 it is again 0. So you will get final answer as 0. So all the diagonal matrix you will get as 0. Fine. As just now we have calculated that the distance between the data point 1 and 2 is 0.71 and the diagonal matrix will be 0. Now you calculate on your own for data point 1 and data point 3. It will look like it is 0.71 again, and data between data point 2 and 3 you will get 1, and the diagonal matrix of 3, 3 you will get the distance as 0. So manual you fill the remaining tables. Either you will get lower half or upper half. Fine. Now our next step is to calculate the distances that have less than 1.4 epsilon, which is equal to 1.4. I have highlighted over here. In first column, these are the three data points with less than epsilon equal to 1.4, and same way for remaining columns till 12th column you need to fill whatever the data points distances you have less than 1.4. Highlight all those data point distances. Now our next target is to calculate the neighborhoods. See, for first data point, what are the neighborhoods? The neighborhoods are should have the distance that is less than 1.4. Epsilon equal to less than 1.4. You can consider all the data points. In this case, consider the first data point. So first look the horizontal way, then you go with a vertical way. So in horizontal way, if you look, there 0 is there, so don't consider the 0. In all the diagonal matrix, you can omit it. And if you look at the first column, you have three data points are neighborhoods, namely P2, P3 and P4. That are the highlighted data values of less than 1.4. So you will get P1 as P1 neighborhood is P2, P3, P4. Same way, now let me focus on data point 2. If you look at data point 2 in horizontal way, you have one value is less than 1.4, that is none other than data point P1, and now you look at the data point 2 in vertical way. So you will get P3, P4, P10 and P11. P10 and P11. Now if you look at P3, horizontal way you just look it out, you will get P1, P2, and if you look at the P3 in a vertical column, you will get P4, P10 and P4 and P8 you will get. For data point 3, the neighborhoods are P1, P2, P4 and P8. For data point 4, you will get the neighborhoods are P1 data point, P2 data point, P3 data point, and for fourth in horizontal way if you look, you will get P8 and P10 as your neighborhoods. Same way you do it till 12. Till data point 12 you need to repeat the process. And if you look interestingly for data point P7, there is no data point in vertical way as well as in horizontal way. There is no data near neighborhoods for this particular point P7. That means this P7 will act as an outlier. We can see that in the upcoming slides. Now in this slide what I have done, for each data point I have mentioned the, and left hand side I have clearly mentioned what are the closest neighborhoods of values that have less than distances less than 1.4. I have highlighted over here, and for each data point I am going to count how many data points are there in each cluster. In each neighborhood, if you consider this as one cluster, how many data points are there, so that it will be easy for you people to count the minimum points 4 and make a core group. So in this slide if you look, as per the total count 4, if the data point is equivalent to in the particular cluster, if you have minimum data points is 4 or more than 4, you can consider it as a core data point. So in this case we have first data point is a core point, second data point is a core point, third data point is a core point, fourth one is also a core point, and eighth cluster is a core point, and 10th one is your core point. Since you have the data count as 4 or more than 4. Now look at P5. The neighborhood of P5 is P12. So you have only 2 data points are there. So it consider it as a noise. For P6 again the neighborhood is P12. So you have only total 2 data points. So you can consider it as also a noise. Even though it have the distance less than 1.4, but it doesn't meet out the minimum point requirement. So we can consider it as a noise. For P7 there is no neighborhood, so you have only one data point, so it will act as an outlier. For data point P9, if you see, there are two neighborhoods, P8 and P10. Even though you have 3 data points in that particular cluster, it will consider it as a noise. And for P11 again it is 2, and for P12 it is 3, so you consider both as a noise. And out of these noises you have 5 noises and 6 cores. We can skip these cores, there is no issue with the core, and there is no issue with an outlier, and some noises are maybe an border points. So we need to check how. We have take the data point 5, consider the data point 5. This data point 5 should present anywhere in this core clusters. Kindly look at the first cluster, whether you have any data point in first cluster. No. So P5 is not there in first cluster. Same way P5 is not in second cluster too. Same way it is not in P3 and P4. Now look at P8. Do you have any clusters? P5 is here, no. And same way in P10 cluster also P5 is not there. So noise is always a noise. Now consider P9. You have P9 is there, right? Now check whether P9 is in any core clusters. For in first cluster it is not there, in second cluster is also not there, third and fourth is also not there. But luckily this P9 is present in cluster number 8. You have cluster number 8, P9 is there. So this ninth cluster, it will act as a border. The ninth data point is a border data point of the particular core. Of which core? 8th core. For 8th data point, it acts as a core point, right? For that particular core point, the border point is 9th data point is a core point. Fine. Same way P11. This P11 present in core data point 2. P11 is presented in data point 2 of core. So this P11 is also a border point. And if you see P12 you are not able to see in any of the core, so it is noise only. Fine. So for first core point, for if you draw the diagram for first core point by considering P1, P2, P3, P4, you can form a first class group as C1. Consider this as your core group 1. Got it? Same way for second core groups, it's a combination of data points 1, 2, 3, 4, 10 and 11. This is your second core point. Over. Third core point, it's a combination of P1, P2, P3, P4 and P8. It is the third core point. And for fourth core point, it's a combination of P1, P2, P3, P8 and P10 as well as P10 only, that's it. Got it? Na? And for fifth core point, it is a combination of P3, P4, 8 and 9. You see, first, fifth core point. And for sixth core point, it is a combination of P2, P4, P9 and P10. And next thing here, outliers, P7, it will act as an outlier. There is no neighborhood for P7 since there is a huge gap. There is no density, high density between 6 and 7 and 8 and 7. You have huge gap, so it is considering it as outlier. Thank you. We'll meet in another video.